Hi everyone, my name is Stefan Kolesnikowicz. I'm here to talk to you guys about some incidents today that we've had at Achievers over the last couple years using GKE. A little bit about myself. I've been a principal site reliability engineer at Achievers for 5 years now. I focus mostly on observability, Kubernetes, Istio, all that fun stuff. I've been working in distributed systems for 20 years. A lot of the people on my team are actually here in this room. I've worked with them for 20 years at different locations. And that really, I feel, makes a really good team and helps us solve some of these incidents in the middle of the night. I have lots to go through, so I'm going to be as quick as I can. I don't want to hold anyone up from lunch, but today I'm going to walk you through 6 stories. I'm going to go over the impact, the resolution, and the lessons we learned along the way. Some of these stories are going to be very, very technical and deal with underlying tools that Kubernetes actually uses, like Linux. And some of the stories are going to be more cloudy, very specific to GKE in general. Sometimes limitations only actually come to you when you're dealing with an incident. So there's no planning. It's just going to happen to you in the middle of the night and you have to deal with it. Before we get started, I just want to explain a little bit about Achievers, just so you get an idea of what we're actually working with. We use Istio really heavily. We have multiple Kubernetes clusters in production. We're across 4 cloud regions globally. And the Achievers platform is an engagement platform for our customers to help build engagement and culture within their business. So we use data to help build recognition and help build culture. We've been going through this monolithic journey for the last couple years now. We have a bunch of microservices in production and we've migrated our monolith into Kubernetes as well. The SRE team is a great group of people, as I was saying before. You know, I've worked with them for over 20 years. It helps our team grow a lot and actually learn a lot. I've known them for 20 years and we're still learning from each other. Quick agenda, again, lots to get through, so I'm going to be as quick as I can. No DNS stories, sorry Marino, wherever you are, but no DNS. I left it out on purpose, so if there is some stories, so if you catch me later, I'll be happy to share some DNS stories with you. So, whom in the room has ever got a page at a very inconvenient time in their life? Like, maybe you don't have a computer near you, whatever. For me, it's always when I'm at my in-laws. I go to Montreal, I visit my in-laws, and for some reason I always get a page there. So this specific one happened in this case where we started getting pages for high latency within our apps, and workloads didn't seem to be scaling. Investigating one of the namespaces, we actually did the kubectl get HPA command to check out what was actually going on. And we were getting a lot of timeouts. We weren't really sure what was happening, but HPAs were timing out. That kind of pointed us to the metrics server. So the metrics server lives in the kube system namespace. We ended up going in there and we saw a lot of pods crashing. On top of that, they were running out of memory. But, you know, we see this problem quite often. You see something run out of memory, just throw more memory at it. So we go and actually try to edit it, and nothing happens. Reverts the change instantly. This is because these pods are managed by Google, and they control all of the bells and whistles kind of behind the scenes that actually touch the requests and limits. So we reached out to Google support. Not with the answer that we had hoped. Thinking this would be a quick and easy fix, they own the pods. They should be able to easily adjust the requested limits. No, that was not the case. We actually heard back from them saying they don't manage these. It is just hard-coded in there and shipped off. On top of that, we actually ran into a bug as well. The reason why that the pods were crashing in the first place is because larger node types had a lot of pods running on them. They would run into this performance issue. So they would start crashing if you had the default amount of pods per node, which is 110. At this point, we had two options. We had to get this up and running because our application was failing. We had to find a way to quickly resolve this because we were seeing intense latency in the cluster. So we had the two options. We could drop the pods per worker node to a value, or we could go and deploy the metrics ourselves. Because this was late at night, we thought number one sounded like our best option to do quick and easy, awesome. So we dropped the pods per worker node to 60. This was not enough. We actually had to go lower. We had to drop that down to 30. 30 pods per worker, that made our node pools huge, because if you have large machine types and you're running a lot of pods there, and then you shrink that and run even less pods, you're getting a lot of extra compute. Now, while this was a kind of one-to-one matching for CPU and memory, you got additional costs added on to that. Google eventually fixed this problem a couple weeks later, and we were able to revert everything, but we were left with a bigger bill than expected. We had more network costs because we had more nodes that had to communicate with one another across region and across zones, along with disks. You have more nodes, you just have more disks. So as a result, we did have this larger bill. It wasn't, breaking the bank or anything, but it was more. Because we use Istio, we do cross-regional traffic, and with more nodes, that's more communication in general. And we also had more zonal traffic. Sometimes the workaround costs you extra money, and just always be ready for that, because usually the workaround is given to you from support, and you should just be aware of what you're changing and if that's actually going to impact your bottom line. Everything is slow. How many people here have gotten a message like that in Slack before, or Teams? And me personally, we get this all the time. No investigation done, just boom, you need to understand what's happening for a developer. So one day I was on my way out, and we got a message in our Teams chat saying, hey, everything is slow. This was only scoped to our development environment, but we have 130 plus developers, and we really don't want to slow down their process and their day-to-day function, so we had to jump on this pretty quick. The specific cluster in question had a lot of performance problems. Running kubectl in general was just giving timeouts, so we couldn't really use that tool to troubleshoot very much. On top of that, we needed extra monitoring because we didn't turn it on in our dev clusters to save some cache. So we turned on the additional monitoring, required a node restart, and we started getting these errors. Newly created nodes during this node pool restart actually started spitting out errors about networking and trying to get IP addresses upstream. So we looked in the UI console, and we saw that there was a lot of network CIDR errors, which is really something you don't want to see. Continuing to poke around in the UI, we also saw additional information we never saw before, even the previous day. This new block that showed up on the top of the screen was saying that there was a new webhook added in the last 24 hours. But we weren't able to see any commits. There was no changes to the actual cluster running kubectl, and we couldn't see any PRs open anywhere. So we hadn't really changed any settings in months, and Google was saying we did something in the last 24 hours. So we reached out to support again, and they confirmed our suspicions. They've turned on something new behind our backs. We had no idea. And we were also doing something pretty silly in the background. So the root cause came down to the kube controller manager. It is responsible for pod CIDR distributions to the nodes, and the APF, which is the API for priority and fairness, was being extremely throttled, which was causing us the timeouts. This is because we had a OpenPA, shoutouts to the security talk before. We had OPA installed that was actually limiting our requests to the kube system namespace and the kube node lease namespace. Once we updated this policy and re-rolled it out, we didn't see the throttling anymore, and everything went back to normal. The big takeaway for us is these knobs and switches that Google has, they can really turn them on at any time. You're not necessarily going to get a notification saying they're going to turn something on. It's just going to happen. Also, don't be scared of the UI. A lot of us are old school and we love the CLI and we try to stay into it as long as possible and do all of our troubleshooting, but just break out of that and go into the UI when you can. It's going to show you more provider-specific information that kubectl just may not out of the box. This was a fun one. So I got a page. I wasn't actually on call. They needed additional help troubleshooting this one. We started getting a lot of 502s from a specific region. Everything looked healthy in other regions. This one region in production was busted. So we started digging and started doing curls ourselves and noticed that, yes, for sure, it was shooting out 502s. One engineer was working on reviewing the logs, trying to find more information and dig in there, while the other engineer was actually going and taking the cluster out of service. One thing that we do really well at Achievers is we treat our Kubernetes clusters as cattle and not pets. So we can really remove one from service at any time and have the other regions take on the additional load. The Achievers platform also uses NEGs, or a network endpoint group, to attach our gateway to our load balancers. And these actually look to be what was failing. We used kubectl port forwarding to test our pods on the gateway layer. Everything looked good. Load balancer, everything looked good. So it had to be something to do with the bindings. The real question, though, was, why are the health checks not working? By definition, a health check is supposed to take something out of service when it is not healthy. But these were still healthy and still accepting traffic. Confirmed. We hit another bug. In order to remediate this issue, we actually had to remove the neg from the load balancer, delete everything, and reconnect it to the load balancer manually. Support said that this is a known issue in GKE versions 1.27 and below, so they just said upgrade it. It commonly happens during a redeployment or a cluster upgrade of those gateway pods that are connecting to the load balancer. We really pressed them for a root cause on this, but they wouldn't give us anything. There must be something proprietary kind of happening in the background that they just wouldn't give us any more information, which was a little frustrating when coming up with your own RCAs. Because the impact was pretty low, we reacted very quickly and we took the cluster out of service. Everything was healthy pretty quickly, so after pressing and escalating it for a little bit, we just said, okay, sure, fine. Something we did really well here is treat our Kubernetes cluster as cattle and not pets. This saves us quite a bit when we're dealing with a regional issue. Sometimes there's cloud secrets that happen on in the background and you're unaware of what exactly is happening. So this happens quite often in any cloud provider. And teamwork. I felt like our incident management process in this case was dead on. We were able to react very quickly and reduce impact. And I think that, again, goes to the team just knowing each other for so long and know exactly what to do in an incident. This next one happened in our pre-production environment. If people aren't aware of PubSub, we use PubSub. It's an asynchronous communication protocol used to put messages into queues and action on them. So our queues were all filling up. We were unsure what was happening, and it was causing a lot of these errors saying we're hitting quotas on the Google API. We could see that the quota was totally saturated, and we had no idea what was going on. It was only happening in one region, but everybody's queue was filled up. Why did this all of a sudden happen? One person on the SRE team was investigating the issue. The other person was going to bump the quota to just try to give us some relief. Once the quota took effect, we could see it completely get saturated once again, almost instantly. Since the messages were not actually making their way to the PubSub API, we knew that there was a service account or somebody making those calls, and probably were able to track that down with some sort of metric. So the service account sounded like the first place to start. Using the GKE metric explorer, we're able to see a pattern of errors from a specific service. This correlated with the time that we started seeing the errors in the logs. From the diagram above, you can see that the issue clearly began and started spitting out 404 errors for this individual service account. By searching that ID, we traced it back to a single microservice, and we noticed that this service was deployed without a DLT, which is a dead letter topic. A dead letter topic is used for failed messages to get reprocessed later on. If you don't actually set it, we had a bug in our code which would actually loop and keep trying to find it, keep trying to find it. It would scale up more pods, and basically you would just have this cascading failure of PubSub saturation. Once the dead letter topic was created, the problem resolved itself, and we went and patched the bug. There was actually two parts of this. One of them was in our IDP, our internal developer platform, where people go and spec out everything that they need for their service. There was an edge case where if you do not create the DLT, you're still able to move forward and deploy. So that was patched. We learned that there was no loss of messages during this time, which was great. Everything queued up. The process worked as we wanted to. Messages are actually kept for 7 days by default, so it was really great that we could replay those at a later time. We did see a cascading failure, which did impact other services, which we would not want to see in the future. So we are going to be figuring out how to address that problem. Luckily, it was only in pre-production, so we were able to resolve the problem before it ever hit production anyways. And the next one. So this one was interesting. We run our pipelines in Kubernetes as well for a lot of things. Not everything, but a lot of them run in Kubernetes. And I came in one day, first thing in the morning, and I saw all the pipelines were failing. And I wasn't sure why. We saw a lot of containers in pending state, and they were unable to do something. So digging into the issue a little bit more, we noticed that this was pipelines that all had PVCs associated to them. Any type of PVC. Specifically though, we saw most of them that had volume snapshot content, which is a tool used to take volume snapshots and quickly mount them to your pods. We use this for testing. So you need testing data, large set of testing data. Just use a snapshot because your pod will spin up a lot faster than trying to rebuild that data on the fly. There's something called the CSI controller, which actually does your disk provisioning, and we were unable to do anything with the CSI driver. It just stopped working, it wasn't sending us any information, and it was timing out. Lucky for us though, we found a snapshot still deployed to the cluster. It didn't clean itself up. Inside the YAML, we noticed that there was a misconfigured project. We were expecting one value here, but it was actually showing us the default value for the deployed Kubernetes manifest. So we found out that there was actually a code change added that gave you the wrong default value and basically deployed it. We were able to track that down to the very, very, very first one that was deployed when this change first happened. Once we deleted that, the cluster came back into service. It was totally fine. We had a cascading failure again. We had one change that happened to one PVC, and basically no other PVCs were able to be provisioned after that. Luckily, we reached out to Google again, and they helped us solve this problem. They were very fast at solving this problem. So they dug into the issue on their end, and they noticed that there's actually no logging for the CSI controller. So any status codes for success or failures, or in this case, a 403 forbidden because it was trying to reach across projects, didn't exist. So they actually went and submitted a ticket and a fix all within 24 hours, which was really impressive. Having no logging actually really impacts your ability to do your job well. So it was great to see Google react so fast to this and solve the problem with such a quick turnaround time. Default values are great. They help you move a lot quicker, but they can sometimes bite you in the ass. This one here is a fun one. This is a little different than everything else. This problem is our most recent problem. It's affected us very recently. We started seeing a lot of high latency during our migration from monolith to microservices. We were moving our big monolith into Kubernetes, and we saw a huge performance problem. We were seeing almost 200 milliseconds more latency on requests, and we were not sure why. Everything looked fine. But we couldn't go to production with this type of performance problem, so we really had to dig into it deeper. This is also one of those problems that you might be focused on for a really long time, and you might need a fresh set of eyes. So you might call in your peers to get a second set of eyes. And wherever Marino is, I told you, no DNS, no DNS stories. So doing some trusty curl commands, in a loop, we were able to actually look at and break down the connection. DNS, again, looked fine. Ruled out DNS, although it was our first thought. The bottom of these two, you could see, is the VM response time versus the pod response time. This is where your Linux chops really come in handy, and you might be dealing with something that's not kubectl, not part of Kubernetes directly. We then thought, what else happens really early on in the connection time? Well, SSL connections happen. We had a hunch that maybe SSL was doing something weird. So we took a look at the SSL library, and we noticed OpenSSL does use libSSL. We wanted to try something that didn't use libSSL. So we found OpenSSL Libra. And this doesn't share the same libraries that we were using in our application. So this was a great example of testing without libSSL. The results were in, and we didn't have the problem. Interesting. That kind of put us back on the right track, that it had something to do with libSSL, right? We also started doing some more research into this and started using tools like strace, ftrace, and started to really dig deep into what the application was doing when it was making external calls. We kept seeing these, like, hundreds and thousands of these messages show up in the output, and it was looking for files that didn't exist. And this was really our first direct clue to what the issue was. We could see that these were all in a NSSDB directory as a temporary directory. And it was going around 1,500 times during every connection. With some Google foo, we were able to narrow down the issue even more and find some more information. So apps using curl or libcurl require libSSL, which actually requires NSS. NSS libraries are made to support cross-platform security-enabled functions such as libSSL. Great. So how do we fix it? Yes, it came down to a Boolean. These are the types of things that really frustrate me. I hate when something comes down to an individual character or a Boolean because it's just so frustrating. It's in your grasp the whole time, but you have to dig through a lot of things to actually find that Boolean. So we were testing it out. Export the library, run the curl, no problem. Awesome. But there's still something underlaying that was causing so much latency to happen, and we weren't sure why it was extra. So we reached out to Google Cloud, and we did some digging ourselves. We do use a tool called image streaming that Google has, and this allows us to stream really large containers quicker to start up. So if you have a 5 gig image and you don't want to wait 10 minutes for it to get downloaded to your cluster and spin up, you can use image streaming, and it basically streams the image and starts the processes a lot quicker. Flipping that on and off actually reduced the issue as well. We don't have much more information into why. We have some theories, but we are still investigating this with Google today. After we set the environment variable, we could see that the latency went back down pretty similar to where the VMs are. So this was a big success for us because we actually did get to solve the problem, and we could move forward and move this into production. Lessons learned. So don't be scared to troubleshoot with your peers. Bring them in. You know, as soon as you can, sit down. I really like having whiteboard sessions. I really missed them during the pandemic. It's really great to be back in the same room as somebody and try to solve a problem. So this was great for us and the team to actually sit down and dig deep into this issue. Also, know your Linux. A lot of people that are new to the industry will jump in and they'll be like, oh, I know Kubernetes. I can run kubectl in a for loop, and really understand the underlying tools that run Kubernetes. Understand strace, LDD, some of these other troubleshooting tools that might help you resolve your problem a lot quicker. Also, it really irks me when there's a Boolean that is the resolution to the problem. Quick review of the stuff that we learned today. For obvious information or specific information that might cut down on troubleshooting, just use the UI. Go there, it's going to give you a lot of vendor-specific information, but it might solve your problem a lot quicker than the CLI. Workarounds might be offered up from support, but they might be at an additional cost, even if it's something small, just like reducing machine types. Even if you're managing a cloud environment, your team will still need to have a deeper understanding of what runs Kubernetes, Linux, for example. Create chaos in production. This is where chaos testing comes in handy, load testing. Have frameworks for these tools that'll help you reduce your blast radius when you are dealing with an incident in the middle of the night. One of the design decisions that we had really early on about failover was treating our Kubernetes cluster as cattle and not pets, and that was great. That really has shown its value to us over the years. New features in managed Kubernetes may be turned on at any time. You have no warning, and you have to be ready for it. One of the reasons we are such a great team is the people that we work with. Don't underestimate the power of in-person troubleshooting, even on a Thursday afternoon. I really love the SREs at Achievers. We are a really great team. As I said, most of us have worked together for over 20 years, and I feel like that really helps us coordinate and communicate better amongst our team. And I don't think any of us would be where we are today without our constant collaboration and teamwork. We are only as successful as the people we work with. Thank you so much.